I want to spend a few minutes now taking a look at more multi-force problems. We're going to spend the next couple of days talking about different scenarios involving multiple forces, right? Most of the things that we've done to this point have been all horizontal, like cars being pulled in one direction, friction in another direction. But this analysis that we use to analyze multi-force problems, applies to any time we have multiple forces, including the problems that I'm going to do here with you today, and including the problems that we're going to do with you tomorrow. First kind of problem that we're going to do is what I call an elevator problem. And the best way to illustrate this is with an example. There's no notes to copy down because it's really the same thing as we've been doing. It's just a different context for using the techniques that we've been using here. All right, the question says a 73-kilogram man stands in an elevator that accelerates downward at a rate of 2.0 meters per second squared. So picture this. Picture this. You're in an elevator. Maybe you're at the top of the CN tower, and you're ready to go down back to the ground floor because you've had enough of looking at the city of Toronto from up high. And all of a sudden, the elevator, it's like the floor falls out from underneath you. You accelerate downward at 2.0 meters per second squared. We want to know the force of the elevator floor that pushes up on him. We want to know the man's actual weight, how heavy he really is. We want to know the normal force acting on the man. And we also want to find the man's apparent weight. Now, this isn't nearly as much work or as difficult as it might seem, because there's only a couple of different things that you're actually finding here. There's 4 questions, but there's only a couple of different things that you have to calculate, and I'll explain that in just a moment. What's the first thing that we do when we're analyzing this problem? Draw a picture. Okay, draw a picture of the guy in the elevator. Here's the guy. He's in an elevator, and he experiences multiple forces. Can you tell me what force or forces the guy in the elevator might experience? What's one of them? Nick? Gravity. Gravity acts downwards on him, right? We can draw that down here. We can draw it down here. It doesn't really matter. We'll draw it right there. It's acting downwards on him. Again, it doesn't matter where we draw it as long as we draw it in the right direction. What else acts on this guy? What else, David? Good, the normal force. Now, is the normal force bigger, smaller, or the same size as the force of gravity? In the context of this question, the normal force is smaller, is less than the force of gravity. Can anybody explain to me how we know that? Why is the force of gravity bigger than the normal force here? Yeah? Good. If he's accelerating downward, if the acceleration is downward, then the net force has to be downward. Remember Newton's second law? The acceleration is in the direction of the net force. So if he's accelerating downward, the net force has to be downward. Therefore, the downward force has to be bigger than the upward force. All right, good. All right. Let's do our thing. Let's say F net is equal to the sum of the forces. It's going to be, in this case, Fg plus Fn. Didn't leave enough space here, but it's okay. We'll go off to the side here. F net is equal to m times a. It's equal to Fg plus Fn. What mass do we have? 73 kilograms. What's a? What's a? Natalie, what's a? Good. -2, not just 2, right? He's accelerating downward, so it's -2. Fg is 73 times 9.81, but we'll make that a negative force. Doesn't matter whether we put the negative with the 9.81 or out front of the 73. Doesn't make any difference there. And we're solving for the normal force, right? What force is the elevator floor pushed up on him with? That's the normal force. 73 times 2 is -146. 73 times -9.81 gives me -716.13. We're going to take the 716 over by adding. And we end up getting 570. Or the normal force would be 5.7 times 10 to the 2 for significant figures. That's how hard the elevator floor pushes up on him with as he accelerates downward at 2 meters per second squared. What's the man's actual weight? How heavy is he really? How did we define weight or actual weight or real weight? 3 words. Force of gravity. All we got to do for the man's actual weight is multiply m times g. It's 73 times technically negative 9.81, but usually when we talk about weight, we make it a positive value. I get 7.2 times 10 to the 2 newtons. Hey, wait, the normal force acting on the man, didn't we just find that? 5.7 times 10 to the 2 newtons. What's the man's apparent weight? How heavy does he feel? What do I got to do for this one? What do I have to do for this one? Miles, what do I got to do for this one to find the man's apparent weight? Sorry? Well, I thought you said something else. I thought you said nothing. What did you say again, Miles? No. What did you say again, Miles? I thought you said nothing. Did you say nothing? Did you say? You don't have to do anything to find the apparent weight? No. Does anybody know why we don't have to do anything to find the apparent weight? Gianna? Because it's a normal force, right? Thank you, Miles. You're right. We don't have to do anything to find the apparent weight. It's just a normal force. Look at what's going on here, guys. We found the actual weight is 7.2 times 10 to the 2. The apparent weight is 5.7 times 10 to the 2. Now, this person's weight doesn't change, but the apparent weight does. Does he feel heavier or lighter than he actually is? Clearly lighter, right? 7.2 compared to 5.7, he feels lighter. You guys ever in one of those elevators that it just drops out from underneath you and it feel like your stomach goes up into your throat? You're lighter. You feel lighter there. And that's because the normal force isn't as big as when you're just standing on the ground. It's not as big as gravity. All right? Here's what I'd like you to do after having gone over this example question. You just got a 4-page worksheet. I would like you for homework, please do all 4 pages of this worksheet except for the last 3. Okay, all 4 pages except for the last 3. So you're doing, pardon me? Hey, look at that. She's a smart one. You're doing the first page, yeah. The questions are number 1 to 4. All on elevators. Okay, draw the free body diagrams. Don't try to skip steps. Draw the free body diagrams. Write the steps out. F net is equal to the sum of the forces and so on. Okay, if you try to skip steps, you'll make a mistake. Okay, show all the work. Take a little bit of extra time. Get the right answers.